Hi, in this tutorial, I'm going to go over VLSM, Variable Length Subnet Mask practice problem. So we're going to do a VLSM subnetting. The network I'm using here is 175.2.0.0, and I do have my network diagram here, and also I do have the chart that I want to use to help me go through the subnetting. So if we look into the topology here, I do have 6 local area networks and 2 wide area network. So local area network, so I have 6, and wide area network, I have 2. So wide area network C and F. And for the local area network, LAN, I do have A, B, and D, E, G, and H. And in VLSM subnetting, we are required to have the right number of hosts on each local area network and on each wide area network. So the chart here, I do have my CIDR value in the chart. I do have number of hosts, which is these numbers starting from 1 all the way to 8,192. And this is the number I'm looking for, the maximum number I'm going to use in today's network example. And these numbers are basically 2 to the power of x, starting from 2 to the power of 0. So 2 to the power of 0 is 1, all the way up. I do have my CIDR notation. The CIDR notation is from the left and going to the right side. Here I do have my host portion of an IP address, and this will help me find the binary bits. So this is and also it's going to help me determine where I am on which octet. So this is my 4th octet, and this is the 3rd octet, and the rest, the 2nd and the 1st octet, is basically for my network portion, which is .2.175, which is I'm not going to change since it's the network portion of my IP address, of the network address. The only thing that we are going to work on, it's going to be the host portion of an IP address. So the first step in doing VLSM subnetting, we are going to arrange our host number from the network from greatest to smallest. So what is that supposed to mean? On each network, we are looking for the required number of hosts. So for instance, we have a local area network H, we have 6,000 here. We do have 200, 100, 3,200, 10, 8 for the local wide area network. We have 2 on each. So basically what we are going to do now, we are going to sort these numbers. So starting from the highest or the largest, which is LAN H, we are going to write down 6,000. Next, I do have 3,200 on local area network E. So here, 3,200. Next, I do have local area network. If you look into G, I have 200. Also, next, local area network D, I have D. For D, it's 100 hosts. And then I do have on B 80. And for local area network A, I do have 10 hosts. And finally, I do have 2 wide area networks, and each are 2 hosts. and it's going to be 2 and 2 here. So now we did the first step towards VLSM subnetting of this network. So what's required next? So next I want to write down the IP address. So starting from the actual IP address here, so I'm going to write down the same IP address that I have. So it's the one I'm using now, it's 175.2.0.0, and this is the actual IP address for my network. Next, I'm going to determine the CIDR notation. So the CIDR notation is actually, or the CIDR value that we are looking for, it's linked, or it has connection to the host. Always remember the CIDR notation, it has connection to the host. So we are connecting CIDR and the host for each IP. So starting from 6000, if you go in the chart, now I'm going to use the chart and look for 6000. Where is it? So here's, I'm going to look into the host part, this part, and I'm going to look into this, and we're going to do some matching. So if we have here 4096, we have 8192 hosts. Obviously, it's always remember it's -2 for the network ID and the broadcast ID. We subtract 2 from the hosts, from available hosts. So you do have available hosts, subtract 2, you do have the usable hosts that you can assign to devices and networking and such. So if we match these values, I do have 4000. Is it enough to make a local area network with 6000 hosts? Can we go back and check this? Obviously no. So we're going to ignore this one, and this is the next value of host. So 8192. Yes, there is some sort of if you look into it, we're going to waste, but the waste is going to be minimized. We're looking for 6000 hosts, but the one that available has 8190 hosts for usable hosts. There is and this is why VLSM coming counts, it's going to minimize the wastes of the available hosts. So here, okay, we find out the CIDR notation that correspond to this value. So this is going to be /19. So here /19. Okay. So this is a /19. So next I want to determine the magic number. And the magic number is the number we are going to use to add to find the next IP address. Okay, so for the first step, the magic number, we need to look into the chart. Then we find the matching on corresponding value, or the location where is the CIDR and the host is located. So here, as you know, we do have the host portion of the IP address, and this, as you know, this is a full octet separated by dots, and this is 8 binary digits. Okay, so this is 8 and this is the 4th. So here we are in the 4th octet, and this is the 3rd octet. Now let's find out the location of the CIDR value and the host that we picked for our local area network H. And if you look into it, we see that this is the location, right? So this is where we found /19. So let's see it. /19, it's located in the 3rd octet, or the host portion. This is the host portion of IP. So this is the 3rd octet. So let's find the binary value for the third octet. And as you know, it's 1 2, it's fixed number 1 2 4 8 16 32 64 128. Again, it's 1 2 4 8 16 32, right? Here the magic number, we selected this area here, right? So the magic number, so the value is here, this bit is on, and it's 32. So our first magic number is 32, right? So now we are going to use this magic number. It's going to be useful for us and for our next determine the IP address for our next local area network. So it's going to be 175.2. Here obviously we worked on the third octet, right? So for the first IP address is /19, and the CIDR value 19 is located within the third octet of our host portion for the IP address. It was here, right? So we're going to add 32 in the third octet. So the 32.0. We're going to do now this exact same step for step number 1, and so on. We're going to continue with exactly the same idea. So the host for the local area network E, we are looking for 3,200 hosts. Okay, here we're going to the charts, looking for CIDR looking for host numbers that it's matching or equal to close to 3,200. And if we look around, here we have /21. The host, it's 2,048, and this is not enough. We are looking for 3,000, so the nearest is 4,094, 4,096, and the CIDR value is /20, right? So this is what we're looking for here. So this range. Here we go. So we turn this bit on for the host portion, and let's go and find the CIDR notation. So that this one, for this one, it's going to be /20, and the magic number, it's going to be, so it's 1 2, this is the third octet, 1 2 4 8 16 32. So the magic number is 16. Okay, next for the 200, and the 200 is local area network G. So here we're going to write down 175.2. Here in the third octet, again, the first two, they used to be in the third octet. So we're going to add 16. This is the magic number where it comes 32 plus 16. So the magic number 32 is from the previous IP, right? So from the previous IP address plus 16 within the same octet. It's in the third octet. And so if you add 32 and 16, so it's 8 4, right? So here we have 448, and here is 0. Again, we want to determine the CIDR notation for the next network is 200. So let's look for 200 here, and the 200 is between 25 24, and this is the 200. That's the location we're looking for. That's the perfect number, 200. This is the nearest number we're looking for, 256 hosts, and the CIDR notation /24. Next, we're going to move to the magic number. This is, if you look after the dot here, so if we look after the dot, so this is the third octet. So 1, 2, 3, 1, 2, 4, 8, 16, 32, and /24 is located on here, on the first bit, so it's going to be 1. That's the magic number. So 175.2, then we're going to add the 1 again in the third, because we're still in the third octet. Don't forget that. We're going to add it to the 48. So it's going to be 49.0. Next, the same step, 100. This is local area network D. So for the 100, let's go and see where can we find 100. And the nearest point we have, it's here, /25. So that's the number here. So /25, right? And that's the CIDR value is 25. Then now we have to determine the magic number. So here we are in the fourth octet. Don't forget that this is the fourth octet starting from /25, and the magic number is 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. So the magic number is 128. So the next IP address is 175.2. It's 49 and .128. So 128 is going to be, as you see just now, and it's the fourth octet because we already work within the fourth octet. So the magic number is on the fourth octet. So next I want to look for my 80 host. So the 80 host is local area network B. Again, we have to look for the CIDR notation here. So for 80, we're looking for a host, and this is 64, this is 128. So the nearest is also /25. It's going to be here. So it's going to be /25. And the magic number is also 128 since this is /25. And now the problem here, we're going to face maximum number problem. So we have magic number 128, and the previous IP it's 128, right? And we supposed to add these two values together, which is going to be 256. This is unacceptable an IP address because we know that maximum number is 255. And so the solution for this is going to be 175.2. We're going to borrow a bit from the third octet to be 50, and this is going to be 0. And the CIDR notation, we're going to start again to determine 10. So we are looking for 10. This is host local area network A. We're looking for 10. So going to the chart and see where's 10. So 10, this is going to be 16. This is the nearest number here. So 16. It's going to be /28. So the CIDR value is 28 for local area network A, and for the magic number, so this is the fourth octet. This is the host portion. This is the fourth octet. We're going to start 1, 2, 4, 8, and 16. So it's going to be 16. Okay, Now here for the last two local wide area network, 175.2. So it's 175.2. Here we do have 50 and 16. So for the wide area network, we are looking for two hosts. So going back to the chart, let's see two hosts here, and here we have two, but keep in mind we are subtracting network ID and broadcast ID. If you are doing designing a network, you are a network engineer or you're working for a network, you don't want the network and broadcast ID. You want only the usable portion of hosts. So you always subtract. So this is going to be actually 0. So actually in VLSM or subnetting, we are not looking at these values. And the maximum we can go to is this. It's going to be /30. It's because 4, we're going to take 4 and subtract 2. And this is giving us 2 usable hosts, right? So this is going to be /30. And this is the side notation. And for the magic number, it's going to be 2. This is it's going to be 4. So the value is 4, the binary digit corresponded value. Next, for the last one is 175.2.50, and the last one is going to be also the same. Since we are looking for two hosts, it's going to be /30. And we have 4, so 16 we already have, plus 4, the magic number, it's going to be 20. And that should be it for this topology that we have. So now that we determined the VLSM subnetting, that we can go ahead and design our network. So we have the table here. We have the IP address now for the network 6000. So this is basically, this is going to be here. This is going to be IP address for this local area network. So this is for H, right? So this is for H, and 3200. This is for E, local area network E. 200 for G here. We have 100 for D. We have 80. This is local area B. 10 for local area network A, and the C and F for the wide area networks. And that's basically it. So for reviewing, so what we did to make this table, so we arranged the host from greatest to smallest. Then I basically put the network ID for the first host, for the first one. We determined the side notation using the chart. Then from this we have the host, so we have to determine the host, then see the corresponding side value, and then we find the magic number. And the magic number is by looking into the binary digit in each octet. Then you are going to add this magic number in the correct octet of your IP address each time. If you have a problem, let's say the magic number plus the previous IP address number is in one octet, it's more than 256, then you have to borrow bits from the next IP and change it. And then finally you can design your network. You can you can now configure your router interfaces with the correct so this is router 1, this is router 2, this is router 3. Now you can configure this interface, you see these interfaces, and this one here for the local area network. This is the first host, and this is the second, since we already wanted 2. So here 2, and also here. These are the interfaces. So once everything configured, now let's say if you have here a couple of devices like PC, laptop, these are going to use the network for D. This is 175.2.49.0, and you're going to know each IP and which network it's belonged to, which local area network. Next, obviously in a practice exam, or you need to also know, or you are designing a full network with its devices and hosts, you're also looking for the host range, network ID, and broadcast ID. I did already video about this. Since you already have the IP address now, now you can easily, I do have an easy method. I created this video, I will leave it in the description. Once you know the VLSM, you're going to go to the video and check the second video on how to find your host range if you want, and a broadcast ID. And that should be it for this tutorial. I hope you enjoyed this tutorial. Thank you so much for watching. Talk to you later. Bye.